Hey YouTube, just wanted to share with everyone a waste oil boiler setup that I've had going for about 3 years now. This one is a setup based on CK Burners instructions that you can get, and this is actually a waste oil boiler. This isn't just a burner, this is a boiler. So I've got the gun right here. See, here's the gun. Got just a little box there. I didn't mount my controls on the gun like they actually specified to do because I wanted to build my own little cabinet for it. Okay, I'm going to give you a look in the burn chamber here. This is the burn chamber is basically three 10-inch tubes, about 30 inches long. And it's just a grain auger that I made it out of. So I arranged 3 tubes in a triangle shape. The bottom tube is the burn chamber, the main burn chamber, the first one. And then the 2 top tubes are just to suck off some extra heat off the deal. And then I have a water jacket surrounding the whole thing. You could see that center bolt right above the bottom burn chamber there. That's actually a plate that you can take off to access the top 2 burn chambers. And if you look back in here, there's a pipe that goes off to the left to go up to the top left burn chamber. So one problem that I have with this thing is when the nozzle plugs up, this first burn chamber will actually fill up with stalactite or whatever you want to call it. It'll create a little mound of creosote here right in front of the nozzle, and it'll completely block the flame. And then the burner will get really choppy. It'll start to cut out and burn and cut out and burn. And that's a sign that your nozzle's plugged, and it's basically just filling up your burn chamber with crud and unburned oil. And I don't know if I show it here, but you can see that little green pail right there. I just have a hose going down to that pail for when that happens, so the oil doesn't just drip out of the door. So this is from CK Burners, this diffuser or whatever you would call it. It's what they suggest to use, and it works really well. So yeah, here's what this thing looks like. Inside here I've got the CK Burners nozzle, and you can see out the right side of that nozzle block is the thermocouple. I just looked on their website. It seems like they've changed their design. I'm not really sure how their new design mounts in there, but for me, I had to bend that bottom plate and put a screw in on each side. And then by doing that, I actually ruined, there's a gasket sealing surface. That bottom plate bolts to the nozzle block, and you ruin that gasket really easily if you overheat your nozzle. So you can see, of course, we've got the electrodes and then the thermocouple out the right side. And that's pretty much all that's going on here. So for the nozzle air pressure valve, I've actually just got, this is off of a plasma cutter. It's a 24 volt DC valve, and it works really well. The one they suggest using is big and it's expensive, and I didn't have it, so this was much easier. Now I was going to open up this, igniter control for you, but there's a little disaster under there waiting for me, so I don't think I'm going to open that up right now. They suggest using some electrodes to contact with the actual sparking electrodes, and I didn't do that because I found a simpler setup. I found an easier way to do it. What I've actually got is 2 little wires that clip right onto this ignition transformer electrodes, and then they also clip right onto the sparking electrodes, and they worked for a really long time until one of them broke. And they were actually from an oil stove. They were from a fuel oil stove. One of them broke now, and it's just kind of resting up against here, and I don't really want to disturb that because it's working and I don't have anything to replace it with. So then, of course, here, I'll go back to here. Here I've got an air pressure regulator. You crank that up and down and set it to whatever you want. You kind of work it around and figure out where it works best, and then really adjusting the air is a big thing. And once you get it adjusted, you really shouldn't need to touch it much unless you're adjusting your air pressure all the time. You just need to match your airflow and your air pressure, and your nozzle temperature is really important. All of that stuff, once you get it burning in range, this thing burns so clean. The smoke that comes out of the chimney on this setup is very clean. You can't actually see the smoke, you can just see the heat rising, and you'll know when you get your burner running good because the smoke will be clean like that. So here I've got a tank. I wish I would have made this bigger. I should have made it bigger. It's basically a tank that has a it contains oil. The whole tank is filled with oil. And then here, this water line and this water line, they actually come from the boiler. These are hot water lines right from the boiler, and they run through an automatic transmission cooler, and that's inside the radiator of every car that has an automatic transmission. And I've just welded it in there, and I put fittings on it. So I'm heating up my oil actually in this tank right here, as well as in the nozzle with that nozzle from CK Burners. What this tank does for me is this tank allows me to heat up and drop out a lot of the crap that's in the water before I try to filter it. That helps tremendously, because I believe that the stuff in the oil, the heavier stuff, will actually drop down to the bottom of this tank along with the water, and then I can open up this valve and drain it out. Right after that, I've got this big oil filter that I found. Finally found one that's a much higher micron rating, because that's what I really needed. Of course, after that, I've got the float tank that they suggest to use, and it works great. I'm not sure what kind of float that I have here is, but I know they're pretty easy to find. I know they're on the internet, and this one works really good. It's never failed me. This tank has never overflowed or anything like that. The only thing that did get kind of weird is this tank, the paint on it was not resistant to oil, and after about 2 years the paint started to flake off, so I ended up sandblasting the tank. Now the problem with sandblasting the tank, of course, turns out to be that you can't get all the water out of the oil. So I'm preheating the oil up there, it's going through the filter, it's coming down into this tank, and the tank is cold, so the water condensates up here, and now I'm getting a little bit of rust up here, and that could be causing some nozzle plugging problems. But nozzle plugging problems have really diminished ever since I sandblasted this tank. I feel like that really helped things. Okay, so after this tank, I've got this really big hose. Gosh, I think this is 1/2-inch hose. And I ended up doing this because this building that this heater is in is actually cold, because it's a waste oil boiler. Even though it says Woodmaster on it, it's a waste oil boiler. So I'm taking the heat from this thing and I'm pumping it. That's actually the inlet back into it. I've got a pump mounted on the back, lots of insulation, and I'm just taking and pumping this water right out through a filter and down into this pipe, and that takes it down and out to the shop. Then the water line comes back. This is just for bleeding air off when you need to. Comes back into here, dumps right back into the top of the boiler. This, I put this here, this is it's an auto bleeder, but it doesn't work in my system because I didn't pressurize my system. I wish I would have, but I I couldn't think of a way to pressurize it and put a water tank in with the kind of float that I wanted to use for my control system. So what I've got here is, I think this is a tank from I think this is a fuel tank from some rig that I just found at the junkyard, and what I did was I drilled a hole in it big enough to fit a sub pump float through, and then I cut a little hole back here for a wire and basically used a sump pump float to decide when my water level was low, so that this thing would never run dry. And the float that I've got there is just the first device that we have to make sure that this thing doesn't start a fire. And actually, it being a boiler is the first device to make sure that this thing doesn't start a fire, because the shed this thing is in isn't important, and that's why we made it into a boiler, so that we didn't have to worry about a shop fire over the deal. If a fire happens, we're going to lose the building and the boiler, but not the shop. So over here we got the cabinet that controls all this stuff. I've got, you know, just a simple burner disconnect switch here. Turn that off, the pump shuts off. Turn it on, pump turns on. Right here I've got the factory safety control from a fuel oil furnace, and this is used for the flame timeout. If the burner is running and there's no flame, it will shut off and lock out. It will not try to restart. It'll just lock out, shut off. Everything will shut down except for the water pump to cool it down, and it'll be done. We'll have to come in here and push the button and try to see if it burns, and if it doesn't burn, then it's most likely the nozzle most of the time. Here I've got the digital PID that, you know, controls the temperature of the nozzle. Once it gets to 170, it kind of floats around that range. It's not perfect, but it works, and it works well. We do occasionally have a problem with this PID, either the PID or the solid state relay inside that's controlling the nozzle temperature. On occasion, the system will fail, and it will fail in heating up the nozzle. Because I've chosen to only heat the nozzle when I'm burning oil, occasionally it will almost forget that it needs to heat the nozzle. It'll sit and think that it's heating the nozzle, and it's actually not. And that's either the fault of this unit here, or else it's the fault of this inside here. So inside here, inside this cabinet here, I have the solid state relay. This is turning on the current to the nozzle. If you tried to use a normal relay for this, you would have problems. Your relay would burn up in really short amount of time. It wouldn't last long because this cycles on quite often. So that's what this thing is doing. This PID that's mounted on the front of the cabinet is basically cycling on and off really rapidly. And then this solid state relay is taking that low amperage output and cycling it on as a high amperage output. So that's what that's doing. This thing right here is something I just had to use because I used that valve from a plasma cutter that I was talking to you about earlier. And this is just a rectifier. That's all it does. It's a bridge rectifier to turn AC into DC so that that valve over there can use it. So this is all relay logic in this cabinet. That's all I did at the time. Pretty soon I'm thinking I'll put Arduino in here and actually program it in C code. I'm a little bit afraid of that though, because you know, I don't want Arduino to freeze and leave all the outputs in the last running state, and that would be kind of bad. So just thought I'd make a little short video of this thing actually burning. Oh, I almost forgot. I have this crappy old air compressor back here. This thing has been in use for 4 years with the oil stove business, and probably 30 years with normal shop business. And what I've done with this air compressor is to make it more efficient. You don't need this thing to run up to 100 psi all the time. All you need out of this air compressor is, I have mine set to about 45 psi, as you can see, and that works just fine. You don't need to pressurize your air up to 100 psi because it'll just run all the time. It's easier for it, and it compresses air faster at low pressures, so it's better for the compressor. It lasts longer. We've had very little trouble with this compressor. Most of it's just been the belt wearing out. And anyways, thanks for watching this video I made here of this waste oil boiler setup that I have. If there's more you want to know about this setup, I have all sorts of information about it. I have wiring diagrams for it. I got a lot of this stuff that I've done with it. I've learned a lot of it from different forums and such on the internet, and CK Burners really has a really good guide on their website, and I swear to God, they're not you know, paying me at all for this video. I just really think that they're a great website. They provide great stuff, and it worked. Versus the methods and different approaches I had tried before, it was a waste of my time until I just, you know, until I just bought the nozzle heater block that I needed and the nozzle type that I needed and the cartridge heater setup, and learning that the PID is the way to go. All of that stuff, once I got it, everything worked perfectly. So anyways, thanks for watching. Keep your stick on the ice.